In this introductory tutorial, you will be guided step by step in creating a parametric model of a simple airplane wing based on the well-known NACA profile. You will learn how to create, manipulate, and parameterize profile curves. The parameterizations will help you define and test geometric variants by changing typical design variables such as angle of attack, aspect ratio, and wing sweep. Firstly, set the orientation to the XY plane by clicking on the Z in the 3D view. Then from the CAD pull-down menu select Curves, NACA 4DS Curve. Rename the created object to something representative such as Profile. The created profile shape is symmetric. We can modify the profile by changing the camber to 0.05 within the Object Editor windows, so that the mean camber line becomes curved. The top surface of the wing is typically referred to as the suction side, whereas the bottom surface is referred to as the pressure side. In order to vary and manipulate the shapes, it is convenient to split the profile curve to form separate curves for the suction and pressure sides. Select the profile curve from the previous step and choose CAD, Curves, then Image Curve. Name the image suction and change the domain from range to 0 to 0.5. Make a copy of the suction definition that was just created and paste it. Change the domain of this copy to 0.5, and change the name to pressure. Turn off the visibility of the original profile curve, for example by toggling the icon to the left of the object name in the object tree. Now only suction and pressure curves are visible. The NACA profile does not have a closed, trailing edge, so we will now close it manually by creating 2 points, and joining them with a straight line. Deselect everything. Create a line by going to CAD, Curves, and select Line and name it Trailing Edge. From the pull-down menu of the line start position, choose the select mode. In the 3D view, select the start position of the curve suction. Repeat this procedure for the end position of the line. Select the start position of the pressure side. The angle of attack of the airfoil section can now be adjusted, for which transformations will be created. Create a transformation by going to the CAD pull-down menu and selecting Transformations, then selecting Rotation. Rename the new object to something meaningful such as RZ. Set the angle to -15 and the principal rotation axis to Z. Select the suction and pressure curve at once using Ctrl, and in the image transformation field choose RZ. In the 3D view you will see that the curves have rotated by -15. Note that the trailing edge is dependent on the curve's suction and pressure, so it will update automatically. The above steps describe the airfoil profile at the root of the wing, next to the aircraft body. For better object tree organization, we put everything that has been created so far into a separate scope. Select all curves and the rotation object and choose CAD, then Scope. Rename the newly created scope to Root. Select the root scope and copy and paste it. Rename the new scope as tip. Finally, create a parameter for the angle of attack. Select the rotation object R, Z from the root and tip scope using Ctrl and, via the context menu of attribute angle, choose create parameter. Name it O4 angle of attack and set the value for a quick test. Parameter O is used for both profiles and can be changed manually. As a result of the previous step, there is a new tip profile, but it is currently identical and in the same position as the root profile. Translate the tip profile along the span-wise direction, the Z direction, by creating a new transformation. Go to the CAD pull-down menu and select Transformations, and click Translation. Rename the new object to D, Z, and set the DZ value of this object to 2. Note that this value is relative to their chord length, which had a default value of 1. Thus the span is 2 times the chord length. Move the DZ object into the tip scope via drag and drop. Add another parameter span for the DZ value and set the value of the parameter to 2. The tip profile will now have 2 transformations. Since we can only put 1 transformation definition into the suction and pressure curves image transformation field, we need to create a transformation chain. First, select the rotation R, Z of the tip scope. Secondly, keep Ctrl pressed and select the translation DZ2. Go to CAD, Transformations, and select Transformation Chain. In the field for Transformation Chain, the 2 transformations are automatically entered due to the previous selection. Rename the object to Total and move it into the tip scope. Next, go to the suction and pressure curve definitions of the tip and replace RZ with Total. Now the tip profile appears at a span-wise offset from the root profile. Next we are ready to create the wing based on the root and tip profile definitions. Select the suction curves from the root and tip scope using Ctrl while selecting. Go to CAD, Surfaces and select Ruled Surface and name the new surface Suction Side. Repeat this with the pressure curves from both scopes. So far, you can change the angle of attack and the span-wise length. Next we will change the model to include variations along the span of the wing. For example, aircraft wings typically have shorter and smaller profiles at the tip, compared with the profile at the root. Go to CAD, Transformations and select Scaling and rename the object S, X, Y. Since the profile was created in the X, Y plane, you can, for example, make the chord length and thickness half of the value at the root by entering 0.5 for factor X and factor Y. The scaling must be added to the transformation chain in the total object of the tip scope, that is, RZ, DZ, SXY. Create parameters again for the discrete values 0.5 for both scaling factors and call them x size and y size, respectively. Viewing the wing from the top, you can see that the leading edge is in a straight line. If you want to have a wing with a swept leading edge, then you can do so with another transformation. Go to the CAD pull-down menu and select Transformations, Translation, and rename the object DX. For the DX value, enter 0.5 so that the tip profile gets shifted in the positive X direction by 0.5. Create a parameter sweep for the DX value. Add the new DX transformation to the total definition, that is, RZ, DZ, SXY, DX. This introductory tutorial outlined a quick and easy method to create a parametric model of a wing. By changing the parameter values, it is easy to modify the profile, chord, span, angle of attack, sweep, etc. Further parameters and transformation can be added to make the wing parameterization more complex, and the variations along the span can be nonlinear functions as well. The procedure utilizing functional variations will be described in advanced tutorials which will outline functional curves, curve engines, and metasurfaces.